Second video, geometric sequences. These ones are a little bit different. These kind of follow more like exponential functions versus linear functions. But they have similar things, right? But the differences would be basically instead of a common difference, a geometric sequence has what's called a common ratio. So instead of adding numbers to get to the next one, it's kind of like you'd actually end up multiplying them. But it really follows exponents. They can be written in exponential form, and the common ratio, which would be written in the nth term, right, in the sequence formula, is going to be the base of the exponent. Right? The number that gets the exponent is called the base. So you're going to see it as an exponent, right? But the base number that gets the exponent, that is what the common ratio is. So no common difference. Common difference is for arithmetic sequences. Common ratio is for geometric sequences, right? But after that, they're very, very similar, right? So the sequence whose nth term is 2 to the n is geometric. Again, they didn't need to tell you that's geometric. When you see something with an like a number with an exponent of n, that tells you right there, boom, we are talking geometric right there. So for this sequence, the common ratio of consecutive terms is, right? Well, it says right here, the common ratio is the base. So the number that gets the exponent is the base. So this one has a common ratio of 2. That's it. You can pull it right out of the formula, right? So again, we're going to go through this the same way. The first term, so a sub 1, right? First term I would just get if I plugged in 1. So 2 to the power of 1 is 2. And that's it. Second term, right? If I want to find the second term of any sequence, I plug in 2 for second term. So 2 to the power of 2, that's going to be 4. And then the third term, right? If I wanted to plug in 3 to get the third term, I could. 2 to the power of 3 is 8. So notice 2, 4, 8, there's no common difference. Not like it goes up by 2 every time. It goes up by 2 and then it goes up by 4. The next one would be 16. So to get it, it's almost like you're multiplying by something. It's like 2 times 2 equals 4. 4 times 2 equals 8. 8 times 2 would get you to 16, right? Or you could think of division. 8 divided by 4 is 2. 4 divided by 2 is 2. They have a common ratio. You can get that ratio by doing division from one term to the prior term. And that's pretty much it. So it's not adding, like it's not like there's a common difference between the numbers. It's a common ratio. So basically you can get to the next one through multiplication instead of through addition. Even though I know it looks like it's exponents, it's more like multiplication to get from one to the other. All right, so this one here, the sequence whose nth term is 4 times 3 to the n. That's geometric. Again, they didn't need to tell me that. If I see an exponent with an n, that tells me it's going to be geometric. But for this sequence, the common ratio of consecutive terms is, it's whatever number that gets the exponent. So this 4 is not part of the common ratio. It doesn't get the exponent. And you wouldn't multiply 4 times 3 and say 12 to the n. Order of operations, you'd have to do the exponent first. So the common ratio here is just the number 3. That's the base. It's the number that gets the exponent. All right, now, so this is your formula for it. Just like with arithmetic sequences, I gave you like mx plus b. We actually ended up using the point slope one more. But this is it for geometry. There's only really one you need to know. And it's like it looks complicated, but it's nice that there's only one of them you have to be aware of. So the nth term is going to be described as a sub 1. So the first term is actually in the formula for us, which is great. And then r just stands for common ratio. That's the r. And then to the power of n minus 1. That's going to be like a fixture for us. It's always going to be n minus 1. And they're all going to follow this format. So it's pretty easy, actually. You take the first term and you write it in there, and then you figure out what the common ratio is, and you put it in there, and then everything else is taken care of for you. Right, so an example, write the first 4 terms in the explicit formula for the geometric sequence. Explicit formula just means you're going to write the nth term. That's it, just in this format. It's just not a recursive formula, that's all. So write the first 4 terms for this, and then that's it. Okay, so first one here, I think I only have 2 examples. Yeah. So first 4 terms, well, I got 1, I got 2, I got 3, I got 4. All right, first term is 1. It's telling me that. First term is 1, so that's easy. And then it says the common ratio is 2, right? So, that just basically means like you're gonna multiply by 2 each time. I'm actually gonna write the formula first, so it makes more sense for us. So the first term, right? So I'm gonna say a sub n is equal to, and if I follow this formula, it's first term, which is 1. They tell me that 1 and then times the common ratio, r, well, r is 2, and then it says to the power of n minus 1. And that's it. That's like literally it. We just wrote it. We just copied this formula. We plugged in the first term. We plugged in the r, and we were done. So notice how if I plugged in 1 to get my first term, even though it told it to me, right? If I plugged in 1 to get the first term, 2 to the 1 minus 1 is 2 to the 0. And anything to the 0 power is 1. So it's just be 1 times 1, which is 1. If I want to get the second term, I can plug in 2. I don't really need to do that, but I'm gonna, right? So if I did 2 minus 1, that's 1. 1 times 2 to the 1 is going to be 2, right? If I want to get the third term, I could plug in 3. 3 minus 1 is 2. 2 squared is 4, right? 1 times 4 is 4. And then if I wanted to get the fourth term by plugging in, I could. 4 minus 1 is 3. 2 to the third is 8. 1 times 8 is 8. But again, keep in mind, if it's a common ratio, if it's geometric, there's a common ratio. And if they tell me the common ratio is 2, that means I'm just going to keep multiplying the number by 2 each time. So the next number would be 16, the next number would be 32, and on and on and on. Right? This one I want you to kind of do on your own. Pause the video and then resume it when you are done. All right, so here we go. We got a sub n, right? We're going to write the formula first. So we got a sub n is equal to the first term. Boom, gives me right there. It's negative 4. And then times r, well, it gave it to me right there. Negative 4 times 4, and then n minus 1. And that's it, right? Just literally throwing these in there for the numbers that they give me. No thought required. But if I want to write the first 4 terms, 1, 2, 3, and 4, again, it gives me the first term as negative 4. And again, the common ratio is 4, right? So I could just multiply these numbers by 4 and be done with it. But if I want to plug in 2 for second term, 2 minus 1 is 1. So 4 to the 1 is just 4. Negative 4 times 4 is just negative 16, right? If I wanted to get the third term, I could plug in 3. 3 minus 1 is 2, so 4 squared is 16. Negative 4 times 16 would be negative 64. But keep in mind, I could just keep multiplying here. Like this times 4 is this. This times 4 is this. This one times 4 is going to be negative 256. So again, there's 2 ways to get there. You can just keep multiplying by 4 until you fill in the next one, or you could actually plug in whatever term number you want for n and fill it out that way. But it's up to you guys. They both will get you to the right answer. I'll skip the summarizer. So you guys are good. Homework tonight is just delta math. You can jump right on it. Good job today.